Good morning. Today I will talk about UML and provide some example because UML is important for design system. We will start from the use case diagram. First, we need to know what is use case. In fact, we already talked about a use case in the past. A use case is a list of actions or even steps. Typically, define the interaction between a role and a system to achieve a goal. For example, if you want to log into a system, you have some step. You need to enter the username, then put the password, then click the button. That's called use case. A use case diagram describes use cases in a graphic way. That means we will use diagram to show the use cases. A use case diagram could be a large or smaller. If the diagram be large, can include a lot of use cases. Sometimes we call this kind of use case as a function. Sometimes we can have a small diagram, just show the basic idea of the use cases. For use cases, also we have many other examples. For example, format document, request elevator. All of these can be treated as use cases. This just shows a use case diagram. This is a point of sale terminal machine. In this figure, you guys see this is a cashier. This is a customer. So for a customer, he can buy something, okay, associated buy something to a customer. Also, he can request refund a purchase item. For the cashier, it can deal with buy item. Also, it can refund the purchase item to a customer, and also it can log in the post machine to do some things. So that's the basic example. If you guys see, there are many other things here. We have a rectangle here. This rectangle we call the system boundary. That means inside the rectangle is the whole system. Also, this kind of stuff, okay, we call it a use case. So we have 3 use cases here. This is another example for the use case diagram. Also, we have a bunch of use case here. This is use case, this is use case, this is use case. Besides use case, also we have this kind of stuff. In the future, we will know this kind of stuff we call actor. Okay? Actor, in fact, means that someone or some system who can perform the use case. So an actor we can associate with some use case. How many actors we have here? 1, 2, 3, 4 actors here. So this actor associate with this use case. This actor associated with this use case. And this actor associated with 3 use cases. And also this actor associated with 2 use cases. In this use case diagram, also we found some relationship. Okay, for example, the relationship called extend. Also, this relationship we called include. This relationship we called include. For a relationship, we talk about the relationship between two use cases. Okay? For example, this extends relationship is between the use case capture deal and the use case limited exited. Also, this relationship include is the relationship between valuation and analysis risk. Also, this relationship is the relationship between price deal and valuation. So this just tell you the basic diagram inside this system. If we go to the original system, we know an actor can associate with some use case, can perform some use case. Also, in this system, this trader manager, they can set limits that he can perform some use cases. Also, for the count system, it can update the counts. For an actor, we know it can be a someone, means human, also can be some hardware or some other subjects, even can be some system. We generally use this simple. For the use case, we all know is some system function. Okay, for example, you can do something. You can log in, log out, or you can check the balance or something. All of these can be treated as use cases. The symbol for a use case, you can use this one. Okay. Also, we already talked about an actor needed to be associated with some use case. So we use a line. This line we called communication line. Okay? So that means this actor perform these use cases. This is the symbols we use in the use case diagram. For the relationship we already talked about, it's between two use cases. Okay? In the use case diagram. A relationship between two use cases we already show included just now and also extends. Besides the include and extends, we also have generalization. This is the third relationship. The symbol to show the include relationship between two use case, use this symbol. Use the dot arrow. Okay. Place order. They will include login. That means login is part of the place order. That means place order include login. For the extends, that means this is the option of the request book. We don't need to search. For example, there is a book there. It's already there. I can just request it. If you cannot find a book, there is an option. You can search it first. That means search is an extension of request book. See here, we put the dot arrow, okay, to the request book. Then put extend here. That means search is an extension of request book. This means just option. Besides the include and extends, we also have generalization. Okay, we use this symbol. For example, you search a book is a generalization of search by author, also search by book title. Okay, search by book title. Okay, that means search a book include two ways. One is search by author, one is search by book title. A search book is generalization of different cases. Even you can search by some numbers, okay? That's the generalization. We already talked about the rectangle. Rectangle, that's called the system boundary. Inside is the whole system. Now let's talk about how to create a use case diagram for a real system. The real system shown here is the home heating system. If you guys show this home heating system here, that's the hot water. Then we have temperature sensor, okay? Then we have water pump. Also we have fuel valve. Then we have a burner. Also we have controller. The controller you can control different things, okay? Also you have a controller panel. In the control panel you can turn on and turn off. Also there is a pump line of the water can go through your whole home. Also there is a temperature sensor. So that's the whole system, and this is the real diagram. So let's how to write the home heat use case diagram. First for the homeowner, then the home heating system is here. We have some rectangle, that's boundary, system boundary. Then inside we provide some use case. The homeowner can power on the heating system, power down the heating system, and change the temperature of the heating system. So this is three usage cases the homeowner can do. So we put the communication link to different use cases. That's very simple. You can modify the home heating use case diagram to be more complex. For example, we add more use case here. For example, pop-up includes adjust temperature. Okay, you can make it 80 degree, 70 degree, and same thing. That's adjust temperature is a process of inside the power up. Change temperature also includes adjust temperature. When you adjust temperature, also you can include make temperature high, and also include make the temperature low. That's include the relationship. This is also include the relationship. Why we use the use case diagram? In fact, the use case generally developed in early stage of development. The people use it for the following purposes. The first is used to specify the context of a system. The second purpose is to capture the requirement of a system. You guys know if you use the language to describe the requirements of system, it's very difficult. But you just use simple use case diagram. That's make it very clear. Also, it is used to validate a system architecture. Also, the purpose is to drive implementation and generate test cases. As we talked in previous lectures, when you test a system, you need to create test cases. Use case diagram you can use to generate test cases. So just now we talk about the use case diagram. In fact, there are many diagrams in UML. So let's talk about what's UML. The full name of UML is Unified Modeling Language. It is a general purpose developmental modeling language in the field of software that is intended to provide a standard way to visualize the design of the system. Unified modeling language can perform visual modeling for object-oriented system, and provide different view of a system, and also provide high degree of abstraction possible. It becomes a de facto industry standard. Also, it includes standard extension mechanism. The bunch of things we can do use this language. UML, in fact, has many components. It has use case diagram we already talked about. Also, it has class diagram, state chart diagram, activity diagram, sequence diagram, deployment diagram, and packed subsystem component. In fact, if you guys really want to learn this language, it takes a lot of time. But what we plan to use just the some of them. This just shows the diagrams of UML diagrams. In fact, UML diagrams can be decomposed on two types. One is called behavior diagram, another called structure diagram. Behavior diagram also include activity diagram, state machine diagram, interaction diagram, and also the interaction diagram also include many other type of diagrams. Also, the behavior diagram also include the use case diagram. For the structure diagram, it include class diagram, component diagram, object diagram, profile diagram, package diagram, deployment diagram, and composed structure diagram. So the bunch of things there, the many details there, the many grammar there. If you really want to learn, it takes about perhaps 1 semester or something. But we really care about just some of them, okay? One is the class diagram. Class diagram, in fact, is similar to the class we used in Java and C++. In UML, the class diagram is graphic notation used to construct and visualize object-oriented system. In object-oriented system, we have a class, okay? Then for each class, we have different objects. So this show one example of class diagram. There is a relationship between this kind of objects and class. So we just use the dot arrow to represent the relationship. Then put instance of. That means use1 is the instance of use. And this one also is the instance of use class. This one is the same. So this just shows the basic concept of class diagram. Definitely, if you guys go online to learn some material, there are many ways to write the class. For example, sometimes they make the class a little detailed. They can use the class name put here, then some attributes put here. Okay, attributes. For example, there is a first name, okay, the last name. Also there is a method here. For example, some other method put here. It's similar to the class definition in Java and C. Also, we have sequence diagram. A sequence diagram describes an interaction among a set of objects. See here, we have two objects, a computer and a server. Okay? Just describe the interaction between these two objects in a cooperation ranged in a chronological order. Not static, it's dynamic. Okay? If you guys see this diagram, a person can check the email, okay? Then first he can send unsent email and send a new email to the server. The server then responds. After the computer receives the response, then it can download the email or delete the email. That means this happens in chronological order. That's called a sequence diagram. Another diagram is called activity diagram. Activity diagram is similar to a business workflow diagram or simply flow chart with much rich syntax. It describes the system activities or the person who does the activity and the sequential flow of these activities. This just shows the example. We start from this point, then come here. They will see whether satisfied condition or not. If satisfied, we can go to next step called warm-up practice. Okay? Then if it's not, put else here. We can go to explain the problem. Then we go on to the next activity, present rules. Then the next activity, call for ideas. Then go on, we have an option here. If satisfy some condition, we go to next. If does not satisfy, we go to this activity. Then go back. When you come here, we also do the choice here to go to this activity or directly go to next step. If satisfied condition, we go here. If satisfied condition, we do the next activity. Okay? Then we have activity here, present idea. Okay? And record idea. Then we go to next. There is some option here. If satisfy some condition, we have time left, then do elaborate on ideas. If no, we just go here. Okay? Then the last step is run up the activity. So this in fact is a flow. It's a flow chart of activities. Definitely about this kind of symbols, for example, and this kind of arrows, you guys need to go to the tutorial to learn them, learn it more. In fact, there are many online resources on VML. There is a good website. I use it for the past teach. You guys can go to this one. Okay. Also, the YouTube, some people provide a good instruction there. For example, I have one example show here to talk about the
Hi, my name is Zach.
class diagram.
Today
Okay.
I'll be teaching you about UML class diagrams. We'll start with some of the basic characteristics, then we'll talk about relationships, and we'll finish up by going through some examples together. Alright, let's talk about some of the basic characteristics of class diagrams. To help explain these characteristics, I'm going to make up an example to help illustrate. So let's say we're building a system for a zoo. And, by the way, these examples I'm going to use probably would never find their way into an actual program, but it'll make all these concepts easier to understand. So in our zoo, we'd want to describe the different things that are in the system. You represent those things through classes, and a class is depicted with this shape here. So what's in a zoo? Well, there are a ton of animals, so we could create a class for our animals. To do that, you just write the name of the class in this top section. If our class is animal, an instance of that class would be a specific animal. So the question is, how would you go about identifying each instance of that class? You do that through attributes. An attribute is a significant piece of data containing values that describe each instance of that class. They're also known as fields, variables, or properties, and they go in the middle section here. So for our animal class, we could create attributes like name, ID, and age. That way we could identify a specific instance of the animal class, like Ruth, ID number 304, age 114. These need to be formatted a certain way though. You start with visibility, which we'll talk about later, the name of the attribute beginning with a lowercase letter, then you follow it with a colon and the data type. For the name, we'd want to return a string, and we can format the other attributes the same way, except that we'd want to return an integer since these are numbers. Now that we've got some attributes for our animal class, we get to the bottom section here. This is where you put methods, which are also known as operations or functions. Methods allow you to specify any behavioral features of a class. So we might ask ourselves, what are some different behaviors of this animal class? Maybe we'd want to be able to change our animals' names. Like Ruth should actually be called Rita. So let's create a function called setName. We could also create a method for eating, since all of our animals eat. Methods also need to be formatted a certain way. You start with visibility, which we'll talk about next, then the method beginning with a lowercase letter. Next, you put parentheses to signify the function you're going to program later. You can also add variables and the data type in here, but in most cases, it's not really necessary. We'll add visibility in parentheses to the eat method as well. Now let's talk about the visibility. The visibility of an attribute or a method sets the accessibility for that attribute or method. So right now we have a minus sign for all of these, which indicates that each of these attributes and methods are private. They can't be accessed by any other class or subclass. The exact opposite is the plus sign, which means an attribute or method is public and can be accessed by any other class. Another visibility type is indicated by the hash, which means an attribute or method is protected. These can only be accessed by the same class or its subclasses. And finally, there's the tilde, or the squiggly as I like to call it. This sets the visibility to package or default, which means it can be used by any other class as long as it's in the same package. But that one is rarely ever used. In most cases, your attributes are going to be private or protected, and methods are often public. Let's quickly review these basics with another example. Let's make a class for employee. We could give an employee the attributes of name, employee ID, phone number, and department. We'll want all of these attributes to be private, and then we could create a simple method like updating the phone number, which we'll go ahead and set to public. So you may have noticed that I'm using diagramming software to create these UML class diagrams. The same principles apply if you're using pen and paper, but diagramming software makes it much easier. The diagramming software I'm using today is Lucidchart, and you can sign up for free by clicking on the link at the top right. All it takes is an email address, and then you'll be able to follow along as we make these class diagrams. So the next thing we'll need to cover are the different relationships that exist between classes. The first type of relationship that we'll describe is inheritance. I'm going to keep going with the zoo example because it makes it easy to understand the logic of these relationships. We'll get to a more technical real-world example later. Okay, so inheritance. Let's say in our zoo, the only animals we have are tortoises, otters, and the lesser-known, but nonetheless amazing slow loris. In our system, we want to distinguish each of them as their own class. So we make 3 new classes for tortoise, otter, and slow loris. And I'll make these a little smaller so you can see them better. Now instead of duplicating attributes for name, ID, and age, we can make these classes into subclasses of the animal class by drawing open arrows like this. This is an inheritance relationship. We're saying that these subclasses inherit all the attributes and methods of the superclass. You could also use the terms child and parent class. So our otter class is going to inherit the attributes of name, age, and ID. And then we could add an attribute specific to otter like whisker length. One of the advantages of inheritance is that if we wanted to change or add an attribute for all animals, we wouldn't have to go in and make that change to tortoise, and then otter, and then slow loris. We could just make the change to the animal class and it applies across all subclasses. In this scenario, we also have what's called abstraction. Animal is an abstract class. Because in our system, anytime we want to instantiate one of our classes, it's going to be a tortoise, otter, or slow loris. We wouldn't instantiate the animal class itself. The animal class is just a way to simplify things and keep the code dry so you don't repeat yourself. So to show that this is an abstract class, we'll put the name in italics. You could put the name inside these things as well, but I prefer italics. Okay, Okay, another type of relationship is association. So if we had a class for sea urchin, we could draw an association, which is just depicted by a simple line, between otter and sea urchin. And we'd say otter eats sea urchin. There's no dependency between them, it's just a basic association relationship, and it's pretty simple. The next type of relationship is aggregation. It's a special type of association that specifies a whole and its parts. So to continue with our zoo example, again, this is just to help explain the logic, let's create a new class for a group of tortoises. A group of tortoises is called a creep, and that's pretty cool. So here's our creep class, and it's got a relationship with tortoise. Any of our zoo's tortoises could be part of a creep, but they don't have to be. A tortoise could leave the creep at any point and still exist on its own. That type of relationship where a part consists outside the whole is aggregation, and we note it with an open diamond. There's also a relationship where the part can't exist outside the whole. It's called composition. To illustrate this, I'm going to create a few new classes. Let's just say we have several different visitor centers in our zoo, and each of those visitor centers has a lobby and a bathroom. Now, if one of our visitor centers was torn down, the lobby and the bathroom of that visitor center would be destroyed as well. Those rooms couldn't exist apart from the visitor center that they're in. That's composition, when a child object wouldn't be able to exist without its parent object. We note a composition relationship with a closed diamond. Another important concept when talking about relationships in UML class diagrams is multiplicity. Multiplicity allows you to set numerical constraints on your relationships. For example, let's say we want to specify that our visitor centers are going to have just one lobby. We simply write the number 1 here, meaning that there can be one and only one lobby per visitor center. But for bathrooms, maybe we want to make it so that there's at least one bathroom per visitor center, but leave the option to have as many as you like. We'd use this notation to denote one or many bathrooms. Other types of multiplicity are 0 to 1, which is an optional relationship, n representing a specific amount, which in our example was 1, but it could be any other number depending on your use case, 0 to many, 1 to many, or a specific number range. Hopefully our zoo examples have helped explain those concepts, but I want to show you what a real-world example would look like. This is a UML class diagram for an online shopping cart, and if you want to look at this diagram with me, just click the link in the top right corner. You can see that the system has several classes and relationships, so let's walk through a couple of them. We'll start with the user class. It's got attributes for user ID, password, login status, and register date. You've got the different return types on the right, and on the left, visibility, which are set to private. You can see how the values returned by these attributes would specifically describe an instance of the user class. Down below, we have a public method of verify login, returning a boolean. And this makes sense, right? Methods are behaviors of a class. So if you were to log into your user account, there's a function in place that verifies your login credentials. Let's move on to the customer class. This arrow tells us that customer is a child of user. So customer inherits all the attributes and methods of the user class. And same thing for the administrator class. Both of these inherit from user, but also have their own specific attributes and methods. Like administrator can update catalog, but customer can't. Stemming from customer, there are several lines with the closed-in diamond. So if you recall, these are composition relationships, which means that the parts cannot exist without the whole. If an instance of the customer class, if that customer's account was destroyed, his shopping cart would be destroyed and his orders would be lost. They can't exist outside of the customer. The same applies for shipping info and order details. If there's no order, there's not going to be any order details or shipping info. The last thing we'll look at in this example is multiplicity. You can see that a customer can have 0 or many orders. Makes sense, right? You could create a customer account for an online store but never buy anything. Or you could be a frequent customer and place several different orders. And on the flip side, an order can belong to only one customer. It'd be pretty confusing if a specific order with a unique order ID was duplicated across several different customers. And here you can see a one-to-one relationship. Each order has one and only one order details, and order details belongs to one and only one order.
Okay, that's the video show. I also put some homework for you guys to do. One is to watch the YouTube tutorial and also go to some online resource to find some tutorial material. Next time I will talk about the special cases on hospital information system and know how to use the diagram we learned to draw the use case for this system. See you next time.